Good day, sir. We are the Group 3, featuring the 92nd element of the periodic table, or the uranium. We will show you how to do the longhand method of uranium using electron configuration, orbital diagram, and Bohr-Rutherford diagram. Let's start with the electron configuration.
Everyone, I'm Lance Aldrich B. Ponyo from Grade 8 Romans, and today I'll be showing you how to solve the electron configuration of uranium. But before we do that, let's start with the basics like the subshells. S, P, D, and F. S can hold up to 2 electrons, P can hold up to 6 electrons, D can hold up to 10 electrons, and F can hold up to 14 electrons. Uranium has an atomic number of 92, which means it has 92 electrons. Now let's start filling them in according to the above principle from lowest to highest energy level. First, we fill 1s2 and then 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 5d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2, and finally 5f4. And that's how we write and explain the electron configuration of uranium.
Hi sir, I'm Zaire Smith and I'm Samonte from 8 Romans, and now I'll be showing you the orbital diagram of uranium. Uranium has an atomic number of 92, which means it has 92 electrons. To show how these electrons are arranged, we'll use boxes and arrows. Each box represents an orbital, and each arrow represents an electron, an upward arrow, and a downward arrow. We follow two rules while filling the orbitals. First, Pauli exclusion principle. Each orbital can hold only 2 electrons with opposite spins. And second, Hund's rule. Electrons fill each orbital one at a time before pairing them. Now, let's fill uranium's orbitals step by step. Let's fill in the orbitals. Let's start with 1s. We'll put 2 arrows, one up and one down, because it can hold 2 electrons, same as 2s. Then we move to 2p, which has 3 boxes. Let's fill it according to Hund's rule. We'll put 1 arrow in each box first, then go back and pair them. So now, we have 6 arrows for 2p6. We just keep going like that for each level. And that's how you draw the orbital diagram of uranium, following the Pauli exclusion principle and Hund's rule.
Good day, sir. I am Juan Gabriel M. Gaviola, and I'm now gonna proceed to the Bohr-Rutherford diagram of uranium. To use the Bohr-Rutherford diagram, you need to draw a circle first, which will be the nucleus, then put the symbol, which for our element will be U for uranium, and its atomic number, which will be 92. Now, in the energy levels, you will need to put the maximum electrons each energy level can hold. To know how many electrons to put, you will need to use the general formula, which is 2n squared. For the first energy level, replace the n with the energy level, which is 1, and solve it. 1 squared equals 1, then multiply it by 2, which equals 2, which means the first energy level can hold up to 2 electrons. And repeat this for every other energy level. For the second energy level, it can hold up to 8 electrons. The third can handle 18 electrons. The fourth energy level can hold up to 32 electrons. The fifth can withstand 50 electrons. The sixth can handle up to 72 electrons. And the seventh can hold up to 98 electrons. After this, you will need to do a ratio, so it will be easier to know if it is correct. Count the number of electrons in each energy level, which in our ratio, it holds 2, 8, 18, 32, 22, 8, and 2. Write it down, then add all of it, and you will get 92. Thank you very much for listening to our discussion about the Longhand method of uranium, electronic configuration, orbital diagram, and Bohr-Rutherford diagram about the element. And once again, we are Group 3 of Grade 8 Romans.